Hey guys, this is going to be part one of the study guide for the physics midterm. We have the breakdown here, and it's going to cover a little bit of everything we've covered so far. You can see I did have to cut out a little bit because we didn't get quite as far as I thought we were going to, so you can ignore the third long things. All right, so up at the top, terms that are important for us to know. Weight and mass. Weight is going to be a vector. Mass is going to be a scalar. So weight is the force of gravity on something. Speed is our scalar. Velocity is a vector. Inertia is a scalar. We don't need to know momentum. Centripetal is center seeking. And centrifugal is really just inertia. So it's an object's tendency to try to keep moving in a straight line. All right, there's a couple different ways to add vectors, which you're going to have to do on the exam. The first one is head to tail, where you actually move the vector over. So if I take this one and I move it over to here, if I draw it the same length and have it pointed the same direction, it's the same vector. And then we would draw the resultant from where the first one started to where the last one ended up. So we start at the back of the arrow and go to the front of the arrow. So my resultant would go from the back of that arrow to the front of this arrow. I can do the same thing here. In this one, I'll move this one horizontally, not changing its length or the direction that it's pointed. And then my resultant is where the first one starts to where the last one ends. So that's our tip to tail or head to tail method, with the back of the arrow being the tail and the front of the arrow being the head or the tip. It's the first day back from break and I'm just not used to talking through the mask. So, all right, two displacement vectors, 2 meters and 6 meters are added together, which are the longest and shortest that the resultant could be. The shortest that they could be is if they opposed each other. So if I had a 2 meter this way and a 6 meter that way, the resultant would start where the first one started, so the back of the 2 meter, and end up where the last one ended up. And so it would be the subtraction of their two magnitudes. The most it could be is if they're in the same direction. And in this case, you would just add the magnitudes together. So 2 meters plus 6 meters is 8 meters. Everything in between those two values is possible if they're not parallel, right? So their longest, once you put this off of being parallel, it's going to be a little bit shorter until it works its way back to the 4. Two displacement vectors, 10 meters and 4 meters, are added together, which of the following is a possibility. So the most they could be is 10 plus 4. The least they could be is 10 minus 4. And so the only one of those that's possible is 7. The 7 is between 6 and 14. All right, mass is a scalar, weight is a vector, speed is a scalar, velocity is a vector, acceleration is a vector, displacement is a vector, friction is a vector, it's a force. Distance would be a scalar, normal is also a force, so that's going to be a vector. The other way that we can add vectors is by solving for the components or just using the components. So these could be given in Cartesian coordinate form, which is x, y, and you would just add the x's together and add the y's together. So I have 5, comma 5, I have 3, comma -2, and this is going to give me 8, because 5 plus 3 is 8. 5 plus -2 would be 3. So my resultant would be 8, comma 3. All right, given the two vectors in component form as 2, -2, and 4, comma 3, what vector added to the resultant would result in no vector at all? So I want to cancel out the vector. So I would line up my components added together, they would be 6, comma 1. To cancel out a 6, comma 1 vector, I would add its opposite. So -6, -1 would give us 0, 0. Given a vector at an angle, we can find out what its individual components are using trig functions. So if I want to get the x component, that's going to be this side of the triangle. This would be my hypotenuse, that's 10. I'm looking for my adjacent side. So I know that cosine of my angle is equal to adjacent over hypotenuse. And I would give you guys this. I'll give you all the equations. I'll give you all the trig things. Even some of the geometry things are constants. It'll all be given to you. I don't expect you to memorize stuff. Memorization is a waste of time. So cosine 30 would be equal to my adjacent side, and we know what the hypotenuse is. It's 10 meters per second. If I multiply 10 meters per second times cosine of 30, I get 10 times radical 3 over 2, which would be 8.66. All right, given the following x and y components, solve for the length of the resultant. So if we have the x and the y components, we can find out how long our magnitude of a resultant is by using the Pythagorean theorem. So this is 4. This is 3. This is going to be equal to 5. So it's a 3, 4, 5 triangle. We know that a squared plus b squared is equal to c squared, where this would be a, this would be b, this would be c. So c would be equal to a squared plus b squared, which is going to be equal to, I said that was a, so I shouldn't write down this. The order doesn't matter. I should be consistent, right? So I'm going to have 4 squared plus 3 squared, 16 plus 9 is 25. Let's go over to that as plus or minus 5. All right, graphs. A number of different things that we could get from graphs. So we should review that real quick. From a position time graph, velocity is going to be my slope. So they're asking, when is my slope -3? The only negative slope I have is this portion. So I should see if the slope of that line is -3. To do this, I need ordered pairs that are on this line. That's a good ordered pair. That would be 6, 3. And this would be a good ordered pair. It looks like it's 7, 0. Slope is y2 minus y1 over x2 minus x1. So this would be x1 and y1. This would be x2 and y2. That's a 0. So I'm going to have 0 minus 3 over 7 minus 6. And that's going to give me -3. All right, an object at rest, that would be a speed of 0. I'm looking for a slope of 0, and that is happening from 2 seconds to 5 seconds and from 7 to 8. So these two lines here. Over what time period is the object moving forward? If I assume that it's starting from rest, that's going to be any time that it has a positive slope. And so that's going to be 0 to 2 seconds. All right, velocity time graphs. A little bit different. In this one, we can not only read the graph and find the slope, we can also find the area. So for this one, our slope is our acceleration. Our area is going to be our distance / displacement. And an object is going to be at rest when our velocity is 0. So what time is the object at rest? They're trying to trick you. They want you to say 0 to 3 seconds, because that's what it would be if we position time graph. You're not going to be tricked. It's actually here, because it's only at rest if my velocity is 0, so from 15 to 20 seconds. How far does it fall in the first 3 seconds? This is going to be my area. For us, this is always going to be rectangles and triangles. That really doesn't show up. I should go to red maybe, huh? That's better. All right, so I'm going to have a rectangle that has a base of 3 seconds, as a height of 30 meters per second, which is going to give me an area of 90 meters. What distance does it fall from 5 to 15? That's also going to be the area, and that's going to be this triangle. So this is not going to be base times height, but it's 1/2 base times height. So my base is going to be 10 seconds, not 15 seconds, because it's going from 5 seconds to 15 seconds. My height is going to be 50 meters per second. So that's going to give me 250 meters. And the last one, what's the constant acceleration from 3 to 5 seconds? This is going to be the slope. So again, I'm interested in ordered pairs. I like this point and that point. Actually, the 4-second point's not bad either. Okay, it crosses on the graph. So I'm going to say that this is 3, 30, I'm going to say this one is 5, 50. So this is going to be 50 minus 30 meters per second over 5 minus 3 seconds. So 50 minus 30 is 20, 5 minus 3 is 2, 20 over 2 is 10. Easy as that. Duck soup. What is the slope of a straight line in a position time graph? This is going to be our speed or velocity. What is the slope of a straight line in a velocity time graph? That's going to be our acceleration. The area under a line on a velocity time graph is going to give us distance or displacement. All right, one-dimensional motion. A car increased its speed from 10 meters per second to 16 meters per second, an average rate of 3 meters per second per second. How much time does it take for it to complete this increase in speed? So our constant acceleration equations, the kinematics equations, we have x minus x naught equals v naught t plus 1/2 at squared. V squared equals v naught squared plus 2a x minus x naught, and v is equal to v naught plus at. The third one looks like the best one for this. So I'm going to subtract my initial velocity to the other side and divide by time. Nope, divide by acceleration because I want time. So that's going to give me 16 minus 10, my final velocity minus my initial velocity, and divided by my acceleration. And that's going to give me 2 seconds. A car starting from rest moves with constant acceleration of 1.5 meters per second for 5 seconds, then travels. It says then, but it should be then, right? You know, fire that secretary of mine. With a constant speed for another 10 seconds, and finally slows to a stop with a constant acceleration of -2. How far does it travel? All right, I'm going to erase this because I have 3 parts. I have part 1. It starts from rest, so it has a velocity of 0. Its acceleration is 1.5, and its time is 5 seconds. So I can find out how fast it's going at the end of part 1 by doing v equals v naught plus at. So this is going to be 0 plus 1.5 times 5, which is 7.5. And then my distance I can find out from doing x minus x naught equals v naught t plus 1/2 at squared. That goes away because v naught 0. So I have 1/2 1.5 times 5 squared. Which is 37.5, I think. I should use a calculator. It's been a long break. See, I would have made a mistake there. This is 18.75 meters. All right, second part, part 2. In part 2, it's going to go at a constant speed for 10 seconds. So my initial velocity is 7.5. My final velocity is 7.5. My acceleration is 0. My time is 10 seconds. This can be easy, right? If I can just say that x minus x naught equals v naught t plus 1 half at squared. In this case, that cancels out. So I'm just going to take my velocity times my time. This I can do without a calculator. That's giving me 75 meters. Part 3. Now I'm slowing to a stop. Again, at the beginning of this part, I'm moving at 7.5. I know my final velocity is 0. I know my acceleration is -2. I don't know my distance or my time. But I do have an equation where it has distance, acceleration, and both of the velocities. So I'm going to use that one. So I'm going to subtract my v naught squared and divide by 2a. So I'm going to have 0 minus 7.5 meters per second squared divided by 2 times -2. I got 14.1. All right, so I'm going to add those. I'm going to add 18.75 plus 75 plus 14.1. And I got 107.85. And on the answer, I have 107.8. But I think it might just be a rounding thing. All right, I'm going to erase some stuff. All right, velocity versus speed. Velocity is going to be displacement over time. Speed is going to be distance over time. So in this part, the first one, you run a complete loop around an outside track, 400 meters in 60 seconds, your average velocity. Your displacement is 0. Because displacement is your final position minus your initial position. It doesn't matter what our time is, but they tell us that it's 60. So that's going to give me a velocity of 0. Our speed is our distance. If we did a lap, it would be 400 meters. Our time would be 60 seconds. So this is going to be 6.7 meters per second is our average speed. All right, that's going to be the end of part 1 of the study guide. Part 2 will be posted directly after part 1.